Hello, and thank you for the opportunity to present in this webinar. Today I'm going to talk about building information modeling and construction demolition waste. To begin with, let me introduce myself. So my name is Vitalij Tetervov, and I'm an information management professional. I've been practicing for the last 10 years. And they have a bit of experience in real estate and infrastructure projects, which is always quite exciting. But in the last couple of years, I've been kind of more involved in the information exchange and looking into structured data to exchange information, which has led me to joining BIMBOX and joining this exciting project, which is called Recon-matic. So in today's session, I would like to cover a few topics. Obviously, I would like to introduce who we are, what we do. Then I would like to establish the grounds for the building information modeling, or in short, BIM. Then I would like to look into the current links between BIM and construction demolition waste. We'll go through the waste generation phases and take a look at the current research in the field. And finally, I'll introduce the Recon-matic project and our challenge that we're trying to solve. So, who is BIMBOX? Well, it was founded, the company has been founded in 2013 in Manchester, and we work across the UK. We have quite a few projects where we're involved, and we try to establish our presence internationally as well. We do work on multiple projects, primarily in information management field, and we work in real estate as well as infrastructure projects. Today, we provide a few services such as information management, strategic support, 3D modeling, and applied technologies. We do provide BIM coordination, model validation. We look into implementation of ISO 19650 series, which is a standard for BIM and information management. So we help the clients to maximize the use of data in construction industry. We have quite a few different clients that we work with. So we work with consultants who design the buildings. We also work with contractors who build them, and we work with the clients who actually operate those facilities. So we have quite a good range of different projects, which gives us a really good understanding of what we're implementing actually works throughout the life cycle of the project. So let's jump into the first subject, which is, what is BIM? When we normally talk to our clients and we mention the word BIM or building information modeling, everybody starts imagining that this is a 3D model, and that's pretty much it. If we look at the actual term BIM, it can stand for many things. So it could be building information model, it could be building information modeling, it could be building information management, or it could be better information management. While there are different definitions, one thing is constant, it's information management. And to be honest, the term BIM originated like in 1960s, when there were no computer softwares to manage 3D modeling. So the talk was actually about data modeling and data management. So rather than concentrate on the technology, we concentrate on the process. And today, BIM is all about the process of how we manage information and data. And currently, it is underpinned by international standards 19650 series, which is applicable across the globe. Over the last probably 10 years of implementing BIM, etc., the industry as a whole was really concentrated on the efficiency. So we look at this value wheel, and all our efforts went into the production and return on investment and life cycle costs, etc. But we have an opportunity to look at wider aims, simply because we collect so much data that we can actually now have a better definition of how we want to utilize that data to inform better decisions. So we have an opportunity to increase the value of our activities to collect data to support environmental, social, and even human goals. As you can imagine, using building information modeling methodologies creates quite a few opportunities. We can utilize these information models for marketing material, for designing, for clash detection, coordinating, for analysis such as structural analysis or solar analysis, etc. We can utilize it for simulations, as well as collect the data through design and construction phases to utilize that data to operate our facilities. However, we have so many different BIM uses, but none of them primarily target waste minimization. So let's have a look at what is currently happening in this field of BIM and construction demolition waste. We have kind of two separate strands. One is BIM, and the other one is construction demolition waste. And they don't really talk to each other, or there hasn't been many use cases. So there are quite a few research papers looking at how it could potentially work, but there aren't many use cases of how it is being utilized on real projects. So on one side, we have all those BIM uses, designed for zero waste. That doesn't require, much. You actually design out the waste. It's probably the best way to minimize waste is to eliminate it. But we know that it's not actually happening on every construction project. So we have other uses such as clash detection, where we can see, where we can build the building in the computer first, make sure everything is coordinated before we build it on site. We can use site utilization planning to make sure that our equipment is stored in the correct way and there is no wastage in that. We can predict how much waste we're going to generate. We can predict how much waste we need to take out, for instance, while digging the foundation, etc. We can utilize point cloud scanning for identifying, the rubble on site. We can use quantity takeoffs to make sure that we understand the actual quantities that are needed to be purchased. So there are quite a few different BIM uses that have the primary focus on time, money, and quality, and the secondary target of waste minimization. On the other hand, we have, initiatives like environmental product declaration, we have life cycle assessment, we have waste classification, but they all seem to sit slightly separately from the building information modeling. There are obviously some research papers looking at how it could be integrated, but it's not yet a widely accepted practice. So if we split all those BIM uses across different stages, we can design stage, we can eliminate waste by designing it out. We can use clash detection tools to make sure that we minimize errors on site. At the procurement stage, we can use quantity takeoff to see how it compares with actual purchase. We can utilize digital fabrication to minimize, again, waste, so it's exact when it comes on site. During the construction, we can use construction sequencing, site utilization, and again, quantity takeoff planning. And at the demolition, we can utilize point cloud scanning to make sure that we have accurate representation of what's on site and what kind of waste we're expecting to see. All of that is underpinned by an electronic document management system to make sure that we're managing this information. Now, I'd like to give you a couple of examples of what is happening at the moment. And again, it's not really a primary focus on, waste minimization, but these use cases can actually be utilized to minimize waste. So one of them is, let's say, quantity takeoff. It is actually quite simple to extract the quantities once you have the model represented digitally, and you can quickly find the amount of material that you're going to use. Combine it with factors of waste, and suddenly you can predict how much waste you're going to generate on the project. Another example could be looking at site utilization and seeing, how and site logistics, and looking at how we transfer waste in the most efficient way. Where do we store it, and how many trucks do you need to come in to pick the waste up, etc. So it informs us to make better decisions. Another use case that I would like to show is laser scanning. So this is an example from MP London, a contractor who is utilizing site scanning every week to identify how much rubble on site they have. This in fact informs them automatically how much waste they will have on site, which informs them how many trucks need to come in and pick that waste. So it's quite a powerful tool to utilize. In another example, we're looking at the databases of life cycle information being connected to building information models. And again, it informs our decision on what material should we utilize to decrease waste or to have a lower impact on the environment. So as you can see, there are quite a few use cases around, and we use different software applications for different purposes. And that creates a little bit of a challenge. So what is that we're looking at in the Recon-Matic challenge? In fact, we have quite a few consortium partners. We have, I think, 23 consortium partners looking at very different fields. But today I would like to concentrate on one subtask of the project, which is looking at building information modeling and information exchange between the software applications. So what we're trying to achieve in this subtask is to define the structured machine-readable information exchange for waste information. You remember I showed you this slide of BIM uses, and to achieve those BIM uses, there are multiple, probably in hundreds of applications that try to, target each of the BIM uses. Now, the challenge begins when we try to exchange the information between the software packages, right? Because each software package will have their own way of working, and to transfer information from one package to another package is quite challenging. So what we tried here at this project is actually define an open BIM methodology to exchange information between those different software packages. And that will eliminate the time you spend on mapping the properties or losing information in the meantime, and actually creating this common thread that we can trust the information when we exchange it. So to date, we have looked at what is called industry foundation classes, or IFC in short. It's a schema that defines every construction product that there is, and defines the properties that should be included. This can be read by different software applications, right? So it doesn't matter what software you use. Once you import that data, your software understands what it is. So if it's a door, the software will understand it's a door, not a window. So as I've mentioned, it could be seen almost like a massive library where you come in and you have all the different components in alphabetical order, right? So imagine it as being a big library. Now, this library, obviously, when you come into the library, you don't really want to read every book. So if you're interested in science fiction, you would go into science fiction department. If you want to pick something for your kid, you would go to the kids section, right? Similar idea is with IFC schema. We don't exchange all the information that's out there. We need to define the purpose of the information. So for example, if you want to coordinate or do a clash detection, you can exchange coordination model view definition to do that particular task. If you want to extract information from your model about facilities management or asset management, you would use something called COBE model view definition. Now, these seem like great ideas, and there are quite a few model view definitions that actually exchange the information for a specific purpose. However, there is a small challenge. At the moment, there is no defined way of how to exchange information about waste. And this is exactly what we're trying to achieve in this project, in this small subtask that we're involved in. We want to define the parameters that are needed to be exchanged about waste. So other software applications, when they receive this information, they understand it. So there is no data loss when we're transferring the information, and we don't have to repeat tasks again and again. In more kind of graphical representations, it's basically what we're trying to achieve is for one software to understand the other. Once you transfer the information, and you can actually transfer it back without any data loss, and that would enable information management in waste industry a little bit more efficient. So it's going to be quite a challenge to define it, and we're really looking forward at what it could be. So we'll be looking at the whole life cycle of waste, where it travels, where it begins, how it is designed, what information is required at the design stage, what information is required at the construction stage, and what information is required at the demolition phase, right? So this is one of the challenges in this project. So I hope you enjoyed this presentation, and hopefully you found it useful. Thank you very much for listening.